VHS. For our purposes here, let's take a look at a few of the commonly used directories in the file system. I've generated this output with a command called tree, which can be installed from the repository. Don't worry about it for now. I just want you to pay attention to the structure of the directories. The most important directory, and the one on which everything else is based, is the root directory, represented with a slash. It's the highest level in the hierarchy, meaning that everything else is contained within it, or is under it. You've probably seen the slash representing root in absolute file paths. Under the root directory, there are a number of other directories with special purposes for the system. Alphabetically, the first one is bin, which contains the command binaries, or compiled programs that make the command line environment usable. These include change directory, copy, the bash shell itself, grep, awk, and a lot more. You can see from the listing here with the arrow, bin is actually a symlink or symbolic link to the user bin directory. A symbolic link is a pointer to somewhere else on the file system. The files we'd expect to find in bin are really in user bin. In this case, to maintain compliance with the file system hierarchy standard, the file system will behave as though bin is a real directory. After that, there's boot, which is where the software that allows the system to start up lives. Among other things, it contains the bootloader, called grub, and the Linux kernel itself. Unless you're doing some pretty specific and advanced things, you won't spend any time in here. Dev is where the system devices are. It contains references to hardware and software resources on the system, and you won't spend much time in here either, but you'll see dev as part of paths that you'll use for various tasks. For example, you might see scripts that send output to dev null, which is a software device that sends data nowhere. Data written here isn't saved, and it just goes away. Dev random and dev urandom are random number generators that can be used for various purposes. If you're working with disks, you'll see things like dev SDA and dev SDA1. This represents serial disk A, the first hard drive, and serial disk A slice 1, the first slice or partition of serial disk A. The etc directory holds system configuration files, and if you make changes to the system, you'll probably do so in here. On CentOS, a lot of the configuration files that you'll work with are inside etc sysconfig. The home directory is where user home directories live. Home folders keep each user's personal files separate from each other, and this folder acts as the default landing spot, or working directory, when a non-root user connects via SSH or FTP. Lib is where library files for system binaries live. You probably won't spend much time in here. The media directory serves as a mount point for removable media, and the MNT directory is where the system mounts temporary file systems. OPT provides a space for software packages to set up their own folder structure. If you work with third-party packages and tools, you might find yourself working in here. The proc and run directories contain some system and process information. Root is the home folder for the root user. Run contains information about running processes on the system. SBIN is where system binaries live. SRV holds information about files for various services. And sys shows information from the proc directory in a different format. The TMP directory contains temporary files and can be cleaned out when the system restarts. The user directory provides another place for applications to live. And finally, the var directory contains variable files that change over time, such as system log files, which can be found in var log. That pretty much covers the directories we'll be working in. If you're using an installation on a cloud provider, your network is probably already configured for the environment your instance is running in. You'll remember that during the installation for this machine, I chose not to configure networking because I want to show you how to do it from the command line. If you set up networking during install, what you'll see will be different from what I have on my screen. You can do a quick check to see if you have internet connectivity by pinging a commonly available internet resource, such as one of Google's public DNS servers. Of course, that's not foolproof, depending on your network policies, but it works for most people. I don't have any connectivity, and I know that my Ethernet cable is plugged into a working network switch. So let's tell the system about the network. The network configurations are stored in the etc sysconfig network scripts folder. Here, there's a file for each interface. I want to work with the first, and in this case, the only Ethernet interface on this system that I'm using here. It's listed as IFCFG-EN01, but if you're using a virtual machine, it might be different. To edit it, I'll type VI IFCFG-EN01. Here, I have a listing of the device name, the hardware or MAC address, and some other information. I want to configure this interface for DHCP, so it'll get an IP address handed out by a DHCP server on this network. To do that, I'll make sure that boot proto is set to DHCP. I'll press I to enable editing here in VI, and mine's already set to DHCP. But if yours isn't, you can just type in DHCP. I'll also make sure that on boot is set to yes. Then I'll hit escape and type :WQ to write the file to disk and quit VI. Now I'll restart the network interface with service, network, restart. And that'll bring up the Ethernet interface with a new configuration. I can type IP-A or IP address, and I can see that now I have an IP address on this network, 192.168.1.3. I can type ping 8.8.8.8 to ping Google's DNS server again. And now I have network connectivity, and I can also route to the internet. Now, since we're configuring a server, and we don't usually want servers floating all over the place, you might be wondering how to set up a static IP address instead of a dynamic one that could change across reboots. There's two ways to go about this. The first is to reserve a particular IP for this system on the network's DHCP server. That's usually done using the hardware ID or MAC address of the system's Ethernet adapter. That makes your network's reservations manageable from a central location and helps to avoid address conflicts. It can make large rollouts easier too, since the reservations can be set up ahead of time. The other way is to set it up manually in the network configuration script. Let's take a look at that. I'll open up the network configuration file again with VI IFCFG-EN01. And I'll make a few changes to it. I'll go into insert mode by pressing I, and I'll change boot proto from DHCP to static. I'll make sure that on boot is set to yes. Then I'll add a few lines. First I'll add IPADDR, or IP address, equals 192.168.1.201. I know that on my network, the DHCP range is from .2 to .200, so this .201 address is outside that scope, and it won't conflict with DHCP at all. Then I'll add a net mask, and in my case, it's 255.255.255.0. I'll also add a gateway, and that'll be the IP address of my router, 192.168.1.1. So this is all we need to specify a static IP address. But since we're not participating in DHCP, we're not going to be handed a DNS server for name resolution. So I need to explicitly set what that server is going to be. So I'll write DNS1 equals 8.8.8.8. That's Google's public DNS server, and that's going to be the first one that I use. If I had others, I could type DNS2 equals 8.8.4.4, for example, and just continue with the numbering scheme. I'll press escape, :WQ to write the file to disk, and then I'll restart the network service to bring up the Ethernet interface with the new settings. Of course, this shouldn't be a problem since I'm connected locally, but if you're connected remotely, keep in mind that this might disconnect you. So if there's a problem with your network configuration, like if you chose an IP that's already in use, you'll need to go log into your box locally to fix it. I'll type service, network, restart, and I'll check out my IP address info with IP space A. Here I can see that I have 192.168.1.201, and let's see if it works. I'll ping a DNS server. That seems to work. And I'll ping something that needs name resolution. And that's